So here's the second lecture in the kinematics unit. It's on distance, position, and displacement. And before we get into to distance, displacement, and position, we should first have an understanding of measurement. So you can measure a number of different things. Some of these things are do not have direction, and some do. And we have words to describe those. Something that does not have a direction is called a scalar measurement or a scalar quantity, and something that has a direction is called a vector quantity or a vector measurement. So here's some examples. Let's say you're measuring how much something weighs or the mass of something. Well, you'd put it on a scale or a balance, and you would get its mass in kilograms or its weight in pounds. There's no direction associated with that. It's just that measurement. Let's say that you are talking about the distance between your home and your school. That could be, let's say it's 5 kilometers. You could say that there's a 5 kilometer distance between your home and your school. If you don't state in which direction you are, then it's a scalar measurement. But if I say that it's 5 kilometers northeast, now it's a vector quantity, and it's rather than a distance, it's now considered a displacement, which we'll get into on the next slide. Other vector quantities would be something like how fast you're moving. When you're given a direction with that, it's called a velocity. So if you're driving on an expressway, you might be driving 100 kilometers per hour. That would be a speed. That's a scalar quantity. But if you are driving and you're stating the direction, so let's say you're traveling 100 kilometers per hour north, now it is a vector measurement. So here's the definitions for a scalar quantity and a vector quantity. A scalar quantity has only a size. A vector quantity has a size and a direction. So the word that you see there as well is magnitude. When you're writing down a measurement, the number, the numerical value, is the magnitude of that measurement. You would also write down the units. And if it's a vector quantity, you would write down the direction. And the convention we use is directions are written in square brackets, which we'll get into a bit later. When we're writing down a variable that it's not clear if it's a scalar measurement or a vector measurement, we often include an arrow over top of it. Some textbooks you'll see maybe write them in bold, but it's hard to do bold writing when you're writing by hand, so we often include an arrow on top. So let's practice a little bit here. For question 1 of the practice here, it says indicate whether this is a vector or a scalar quantity. So the first one we have 50 kilometers per hour. There is no direction given, so that's a scalar quantity. For B, it says 6 kilometers per hour north. And notice that the direction here is given with square brackets. That would be a vector quantity because we're given a direction. C is a density, 2,000 kilograms per meter cubed. There is no direction associated with that. That's a scalar quantity. D is a time measurement, 6 centuries. That is scalar. E is a mass, 800 kilograms, doesn't have a direction. F appears to be a mass value per week, so it might be how much somebody is losing in mass. That would be a scalar quantity. G is a velocity, 20 meters per second. Direction is given south, so now it is a vector quantity. And H is a force, 400 newtons acting down. That is a vector quantity. Distance is the total length of the path traveled by an object in motion. So distance is a scalar quantity, and we represent it using just the letter D. If you walk directly from home to school in a straight line, it says here in this example, you would travel a distance of 500 meters. If you walk from the school to the library and then return home, you travel 1,900 meters. So you'd have to travel 700 meters plus the 1,200 meters. That is 1,900 meters. Position is the distance and direction of an object from a reference point. So position is a vector quantity. It's represented by the symbol d with an arrow on top. So for example, if your home is the reference point, the school is position 500 meters east. The mall would be 1,000 meters west. The library, 1,200 meters east. So note that the magnitude of the position is the same as the straight line distance, but we have to include the direction when we're talking about position. Displacement. This is the measure of the change in an object's position. So displacement is its final position minus its initial position. And displacement is a vector quantity. The symbol for displacement is delta d with an arrow on top. Delta is it's actually the Greek letter D. It stands for difference or change. Whenever you see a delta in front of a variable in physics or in other sciences, it refers to the difference between an initial and a final position, or an initial and a final measurement of whatever value or whatever quantity you're trying to measure. So again, here's with displacement. It is the final position minus the initial position. So here we have displacement, and it says here, as with any change, displacement can be calculated by subtracting the initial position vector from the final position vector. When an object changes its position more than once, our total displacement is the sum of each individual displacement. So here, our total displacement delta dt is equal to delta d1 plus delta d2, and so on and so forth. Here's an example for displacement. It says if you walk directly from home to school, that would be 500 meters east. Your displacement would be 500 meters east minus 0. If you then walk from the school to the library and then return home, your displacement will be 0 meters, because 500 meters east plus the 700 meters east you would take to travel to the library has to be added with the 1,200 meters west. That brings you back to 0. Here is a nice summary of these definitions. Distance is the length of the path traveled by an object in motion. Position is the distance and direction of an object from a reference point. Displacement is the change in position of an object. And the note here says the SI unit for distance, position, and displacement is the meter. This page, you'll see some pages like this where they give you equations. You will have, or you might have already noticed that you have a formula sheet. But here are some formulas, one for displacement, one for total displacement. It might be worth copying this down, because this then gives you a definition of what each of the terms mean. And it summarizes everything in a nice simple place for you. Here's another practice question. It says, what is your distance and displacement if you walk from home to the library and then back home? So the distance to the library is 1,200 meters. If you walk to the library and then walk back, you've traveled that distance twice. So your distance traveled is 2,400 meters. Your displacement, though, is 1,200 meters to the library going east, and then 1,200 meters to going west back home. Let me show you that on on the paper here, so that you can understand it a little bit more. We have our displacement, delta D with the arrow on top, is the position vector 2 minus the position vector 1. And position vector 2 is 0, because that is the point where we start, home, minus position vector 1, which is 0. So our displacement is 0 meters. Said differently, our total displacement, or our resultant displacement, is the sum of each individual displacement. So my displacements are the distance traveled to the library, which is equal to 1,200 meters, and I'll put the direction east, plus the distance traveled from the library back home, which is 1,200 meters west. Now, I don't write the unit when I'm writing this down as an equation, but I do write the direction. And the reason why I'm writing the direction is because it helps in determining whether I'm adding this correctly together. This should be a square bracket. My square brackets sometimes look like C's. When we're working with vectors, it's often taken that sometimes it's assumed which direction is positive, which is negative, but it is a good practice to state here, and I'll do this on the side, assume east is positive. So my east direction is positive. That means on my next line, I can rewrite this without the directions. But if east is positive, I write the 1,200 as a positive number. The west becomes negative 1,200. And when I add 1,200 plus a negative 1,200, I get 0 meters. So those are two ways of finding the displacement for that question. It's worth kind of understanding both of them, because those methods you'll be using throughout the course. Here, this question is similar. Now it says, what if you walk from the school to home and then to the library? So if I walk to the school, that's 500 meters. I walk home, that's 500 meters. And then I walk to the library, that is 1,200 meters. Sorry, I misread that. If it says I'm starting at the school. So if I walk from the school to home, that's 500 meters. If I then walk to the library, that's 1,200 meters. So that's 1,700 meters altogether. Now let's look at the displacement. And I won't write this one down, but we'll talk through it. Let's look at the position, the change in the position vector. So I initially start at the school, which is 500 meters east. I end at the library, which is 1,200 meters east. So 1,200 meters east minus 500 meters east is 700 meters east. Another example using the same image here. What if we walk from home to the school and then to the mall? So if I walk from home to the school, that's 500 meters. To walk to the mall, that's going to be another 500 meters to walk back home, and then 1,000 meters to walk to the mall. So altogether, a 2,000 meter distance. The displacement we'll look at as a subtraction between initial position taken away from final position. So the final position is 1,000 meters west. The initial position is home, which is 0 meters. So 1,000 west minus 0 is 1,000 meters west. Here's another problem. A dog practicing for her agility competition leaves her trainer and runs 80 meters west to pick up a ball. She carries the ball 12 meters due east and drops it in a bucket. So what is the dog's displacement? Now let's do this one here. I'll calculate this. So first, we have this dog. It is at an initial position. We'll just show it here. It says that the dog leaves the trainer and runs 80 meters west. So I will just give another position here. This is an 80 meter distance. And then it carries the ball 27 meters east. So then it carries the ball 27 meters east. What is the dog's displacement? So the displacement is the sum of each displacement. So it's delta D1 plus its delta D2. And that is equal to 80, and that is traveling to the west, plus 27 traveling to the east. Now I could say east is positive, but in a situation like this it might be better to assume, or we can say west is positive. That would be 80 plus negative 27. Combining those together, we get 53. And now we have to bring our direction back in. This is 53 meters. It's a positive number, so that means that we use our positive, which is west. And the last question, a car changes its position from a position of 52 kilometers west of home to a position that's 139 kilometers east of home. What is the car's displacement? And we'll do this one here as well. So we have a car. So its home is some location here. Let's say that we'll make home here just so we can show it visually. It is initially at a distance of 52 kilometers west of home, and it ends up at a position that is 139 kilometers east of home. Well, in this case, we can add these displacements again, and its first displacement plus its second displacement, let me just write that fully. Its first displacement is 52 west. The second displacement is 139 east. Now let's define one of these as positive. Just a second. Okay, let's solve this one by looking at the change in position. So, because we're given two positions, so our delta D, which is our displacement, is equal to position 2, the final position, minus position 1, which is the initial position. That is, our initial position is 52 west minus 139 east. And in this case, let's say we'll make west positive, so we could choose either way. West is positive. That gets us to 52 minus negative 139. And when we subtract a negative 139, it's the same as adding. So we end up with 191 meters, and this would actually be to the east. Why is that not working? Okay, so we'll figure this out by looking at the change in position. So that is my position 2, my second position, minus my position 1, which is my initial position. My second position is 139 east, or my final position, minus my 52 west. And in this case, let's say east is positive, because I start with an east here. This then becomes 139 minus negative 52. And when we subtract a negative, it's the same as adding. So we end up with 191 meters. And because this 191 is positive, it's to the east. And that is all for this lecture. Make sure you check the next one.